Hello, this is Mr. Stansbury. I'm going to take you through the notes on use square roots to solve quadratic functions. At the end of this, you should be able to say, I can solve simple quadratic equations where b equals 0, use those equations to model real-world scenarios, and I can explain the steps to solve a simple quadratic equation by using square roots. Okay, so let's get straight into an example here. Consider the graph of f of x equals x squared, which is here. How many solutions do each of the following equations have? How does the graph represent these solutions? So we want to know when x squared equals 9. So really it's usually you see this as, like say f of x equals say x squared, right? So we want to know when 9 equals x squared. So really the 9, that's going to be our y value, right? So when does y equal 9? So up here at 9. So all along this line here is when x squared equals 9. So it's got two different solutions because it's all it's asking is how many solutions does it have. So this one here is going to have two solutions. Okay, at x squared equals 8. Same idea. Oops, wrong button. Uh-oh, froze it. Okay, there it goes. At 8 here, so what we want to do is just make another line here at 8, and there's 1, 2, oops, bad one there, but 2 solutions there as well. We don't have to come up with the solutions, we just have to say how many there are. At x squared equals 0, that's right down here, and that, you can see, only has one solution. And then x squared equals 1, negative 1 is down here. So that is this here. And you can tell there that there are no solutions. Okay. Now, what can we conclude about the number of solutions for the equation x squared equals a? If a is greater than 0, that means 2 solutions. If a equals 0, that means we get exactly 1 solution. And if a is less than 0, we get no solutions. Now these here are actually talking about real solutions. Okay, there's 2 real solutions, 1 real solution here, and there's no real solutions, but there are 2 what we call imaginary solutions. Okay, which I know is a little bit weird, but basically you can't graph them on there, but they are imaginary solutions. So what we have, something that you'll want to know, is that I is imaginary equals the square root of negative 1. Okay, and that is what we call the imaginary unit. So if you got the square root of a negative, you can, like, say if we had square root negative 9. If you put square root of negative 9 into your calculator, which we'll just do that right here just to prove a point here, we're going to do the square root of negative 9. It's going to give us an error because you cannot take the square root of a negative number. It's not going to work. So what we can do is we can say, oh, let's split this up into the square root of negative 1 times the square root of 9, because we know that the square root of negative 1 is now just plain old I. And then we write square root of 9. We know that that's 3. And then what we always do is write the real numbers and then the imaginary numbers after it. So we would say that it is the solution to this would be 3i. Okay? Okay, so now with that, let's take a look at some examples here. Okay? So we're going to solve and describe the number of solutions for each one of these, and then we'll look at example 3 here in a second. So, solve and describe. So we want to isolate. The big key here is you always want to get the x all by itself on one side. So if you'll remember good old PEMDAS, right? The please, I learned it as please excuse my dear Aunt Sally. Okay. So we do parentheses, exponents, multiplication, division, addition, subtraction. Now, and then these always go together, and these always go together. Now, when we're solving, we want to do the opposite. So we want to add and subtract first. So we're going to go this direction. We're going to add and subtract first. So the first thing we want to do, add 8, 3x squared equals 8. Divide. Now we'll do multiplication and division. So divide both sides by 3. X squared equals 8/3. So then we're going to square root both sides to get rid of the x, and we get x equals, and what do we square root? Plus or minus. And we got the square root of 8 over 3. Okay, plus or minus square root of 8 over 3. Now, officially we cannot have a root in the denominator, so we have to do what we call rationalize the denominator. So easiest way to do that is think of this as the square root of 8 over 3. So I'm just going to do this. Square root of 8 over square root of 3. And there's our fraction there. To get rid of that root 3 on the bottom, we simply multiply top and bottom by root 3. Because that will give us, we got plus or minus. We got 8 times 3 is what, 24? And then root 3 times root 3 is root 9, which we also know is just plain old 3. Oops. We've got to do the plus or minus. And then we know the denominator now is 3. And then 24 is going to break down into, we want to try to get perfect square factors out of it. So 24 is the same thing as, let's see, I usually start with the perfect squares. So 1 obviously isn't going to help. 4. This works to be 4 times 6, right? And 6 doesn't have any other perfect square factors in it. So we say square root of 4 is 2, and then we just leave the root 6. So the square root of 24 is the same thing as 2 root 6. So we get our final answer is plus or minus 2 root 6 over 3. Okay? Okay. Let's take a quick little comedy break here.
So much the number, man, it's I feel old. Some things happen to make me feel old. For example, I read an article not too long ago. Society says the average man at 27 should be married. It's very depressing. So I don't think society factors in things like maybe me and a wife at this point in my life can come together and fit in my mom's basement, because it's not that big. It's finished, but it's damp. She ain't gonna want to do it.
All right. Same idea here. We're going to get the x squared all by itself and solve this thing and see what we get. So we're going to subtract 31 from both sides. And we get 16x squared equals 6 minus 31 is what? Negative 25. Divide both sides by 16. And we get x squared equals negative 25 over 16, right? So we square root both sides. And we get x equals, now look, we got a negative. We can't have that. Can't do square root of a negative, so let's do this. We're going to rewrite the top as a square root of negative 1, and the square root of 25, and the bottom as a square root of 16. Okay, so this negative 1 turns into an I, right? Square root of 25 is 5. And guess what? The bottom, we don't have to do this rationalize the denominator because square root of 16 is 4. So our solution is going to be plus or minus 5i over 4. Okay? All right, moving on to C. Same idea. So we're going to add and subtract first. So subtract 4 from both sides, and we get x plus 2 squared equals 9. And now we have to do the square rooting first because we have to get rid of this square. We can't just get rid of the 2 first because that 2 is being squared here. So we got to undo the square. So we've got to square root both sides. So over here, this square and square root cancel each other out. So we get x plus 2. And that's going to equal plus or minus square root of 9 is 3, right? Now we can go back and get rid of the plus 2. So we subtract 2 from both sides, and we get x equals. Super important when you subtract 2 from this. You don't want to subtract 2 from the 3. You want to subtract 2 from, like, if this is plus or minus 3. Let's think of it really as this. Let's think of it as 0 plus or minus 3. And we're going to subtract the 2 from this 0 out here. So we get negative 2 plus or minus 3. Okay, and if we do each one of those, negative 2 plus 3 and x equals negative 2 minus 3, we get that x equals, let's do this over here so it looks a little bit better. So we know that x equals 1 or x equals negative 5. So we get those two solutions for this one here. Okay, let's do this one here. Nothing to add or subtract, but we can divide both sides by negative 2, and we get x plus 5. Oops, that does not look like a 5. That looks like a 3. X plus 5 squared equals negative 4. Next thing we got to do is get rid of the square. So we got to square root both sides. Those cancel, and we get x plus 5 equals. Square root of negative 4 is really, if we write it this way, square root of 4 times the square root of negative 1. The square root of 4 is 2, and the square root of negative 1 is I. So we get 2i like that. Okay? Now, last thing we need to do is subtract 5 from both sides. Now, it's very important to note that this is a real number and this is an imaginary number. Real numbers and imaginary numbers don't play together, so we keep them apart. Okay? It's kind of like saying, like subtracting 5 from 2x. 2x minus 5, you would just write as 2x minus 5. So we're going to do the same thing here. We always want to write the real numbers first, so negative 5 plus 2i would be our solution here. Okay? All right, one last one, and then we'll do a second video with a few more examples on it. Give a value that ensures 2 times x minus 3 squared minus 6 equals a has only one solution. Okay, so we just want to make sure that we get this side over here equal to 0, right? So all we really want to do, what I would do here is just say 2 times x minus 3 squared minus 6. We want to know when that's going to equal 0. So then let's just solve this thing here. And we add 6 to both sides. 2 times x minus 3 squared equals 6. Divide both sides by 2. And we get x minus 3 squared equals 3. Right? And we want to square root both sides. So we get x minus 3 equals plus or minus root 3. And then we go up here. Just going to rewrite it again. X minus 3 equals plus or minus 3. Add 3 to both sides. And this is going to work as long as x equals 3. Oops, that's supposed to be root 3, right? 3 plus or minus root 3. Okay, and just to show you that this works, 2 times 3 plus 3, 2 times 3 plus the square root of 3 minus 3 squared minus 6. So that's just this here with 2 or 3 plus root 3 plugged in there. That's one way to equal 0. And then if we go back over here, push enter, it's a way that you can go back and get your original equation and just edit it. It's just highlight it and then push enter. And then now we're going to do, we want to turn this plus over here to a negative. And then if we push enter again, we should still get 0, and we do. So those are our two different solutions. Okay? If you have any further questions on any of this, please feel free to ask in class. Thanks.